Hello everybody and welcome back. So this is the final lesson of week 1 where we've been discussing HScript and HScript expressions, and this is part 2 of the lesson where we are just running through a few examples of common expressions and how to use them just as a little bit of practice to make sure that we know how to build expressions, we know how to use them. Hopefully this will highlight whether you've been following or if you're confused at this stage. Definitely I would suggest going back, re-listening to the lessons, but doing a bit of self-study and making sure that you can do what we're doing in this lesson before moving on. Because even though this is not Vex yet, a lot of these expressions are used in Vex, because in your Wrangle nodes you will create parameters and you'll have these expressions in those parameters. And a lot of these functions have an equivalent Vex function as well, so definitely worth learning. Okay, so we're going to start with a few string expressions now. So what I've done is I've created a string in here referencing a material, and I will actually create the material so that it's that it finds it correctly, right? So we're pointing to a material, okay? And I've done this just to kind of have a long string in here that you would actually want to maybe reference, okay? And I'm going to just use this categories string parameter just as a place to run our expressions. So the first one we're going to start with is substring. So remember, we're going to start with a backtick because we are working in strings, and sub-str is the expression, okay? So that stands for substring, okay? Now, what this is going to do is we reference a string, or we feed it a string, okay, as the first input. Let me just put the brackets here so this comes back up. So the first input is a string, then the second and third inputs are the start and the length of the substring that we want to extract, okay? So I'm going to copy this parameter, and then remember I'm going to click in so that my cursor is there so that when I paste it doesn't replace, okay? Now one thing that you'll see is when I've pasted inside of a string, it has automatically added the backticks for me, okay? It doesn't look backwards and figure out that there already is a backtick. So if you're in the middle of an expression, you actually need to remove these backticks, because the second backtick, if there was one here, is essentially ending this expression at this point, and then this goes back to being a normal string. And then if there was another backtick here, then this is the start of another expression which doesn't exist, and that's obviously not the result that we want. So we're going to get rid of the backticks so that we only have one, which begins the start of an expression. And only when we have the next set of backticks at the end of this will it finish the expression. Okay, so this is a reference to the string. Then we are going to pick the starting point within that string to start our substring. So the first character is 0, then 1, 2, 3, 4, and 5. So let's stop at 5. Okay, so if I give it the number 5. And then as the last argument, now this is not a range, so it is not the start and end, it is the start and then length. So if I say 5, it will give me from the 5th character, and it will give me 5 characters, 1, 2, 3, 4, and 5. Okay. Don't worry about the error. This is just the expression is correct. It's just that it's erroring because this is not a valid string to be in this location. Okay, so substring, very useful. Also string len is another one that we use quite often. So this one just very simply takes a string, so same thing. I'm just gonna paste and clear the backticks, and this is going to give me the length of the string. In other words, the number of characters in the string. Now, there can be a lot of uses for that. sometimes you know exactly how long a string should be, but the primary use of this, or at least in my experience, when I most often use this, is simply to check whether there is at least some characters. Okay, so essentially you're checking, is it 0 in length, or is it more than 0? Because then you're essentially running a check to say, has the user typed something or not? Okay, so we could say here stringlen greater than 0. Okay, and then maybe put this inside of an if. Okay, so this is our condition, so we'll put this inside of an if. But remember, we can't just type a normal if. A normal if is going to expect us to feed it a float and then 2 floats. So the condition, which we have, which is a float, but then what we want to return is not a float for true and false, but we want to return a string. So there's the if s. Okay, so don't forget that, right? If you run the if s expression, then it allows you to return strings as your true and false statement. You'll see here string if s, and it's float string string instead of float float float, right? So we can say, I don't know, something, can't spell, but anyway, and else. Okay, so if it has something in here, then it will return something, spelled very badly. Or if I remove it entirely, then it says else. And if there's any characters, it will jump back to something. Okay. So remember, I even showed you in the previous lesson that when we have that attribute create and we were using the create local attribute, when this is ticked on but this is empty, it takes the capitalized version of this. Essentially behind the scenes there's a similar function running saying, if the user has typed anything here, then take what they've typed, but if they've typed literally nothing, then do a different function. So that's kind of what you would be building here with this. Okay, let's just undo so that we can get back to our string. Okay, so that's a stringlen function. Then also there is a string replace, str replace. Okay, and what this lets us do is replace words inside of the string with something else, or characters inside with something else. Okay, so we feed it the string, and again I'm going to remove the backticks, it's a bit annoying, and let's say we want to replace all of the slashes with maybe underscores or something. So all we're doing is feeding it one string which it's acting upon, searching for all of these characters and replacing it with these characters. Okay, and that's the result. So you can use this to strip out white spaces, you can use it to replace backslashes with forward slashes, take out underscores, replace spaces with underscores if you want something to be a valid name, like you'll see here in these. If there is a space, it automatically swaps it for an underscore. So you could use it as a way to run through your, if you leave a space, and replace it with, I guess, underscores. So then it'll return exactly the same, but let's say there was a space in here, then it's going to return an underscore. So then you can make sure that it's a valid name for a node, or something, something like that. Okay. So that's string replace. Then we have another one, which is string match. So this is a condition, and it is basically checking whether there is or isn't a match inside of that string. Okay, so you're searching the string for a particular phrase or a bunch of characters. Okay, and you can use wildcards in this case. Now, this is a weird one. This is why I say always have the help file, because there are a few that catch you out, and I'm not even sure why they've done it this way. I mean, maybe just to keep us all on our toes. But So this one, normally I've told you that the first argument that you feed it is the one that it acts upon. So you would actually assume that it would be your string, and then you'd search that string for, something. I don't know, let's say star shop star, okay? This will not work, all right? Because weirdly enough, and I have no idea why, this expression is the other way around. You feed it first your list of what you're looking for, and then the string, and then it searches. Okay, so it's saying 1, as in true. I have found the word shop inside of this, which is finding it there. Okay. Now you see this one uses wildcards. So if you take the wildcards out, it'll actually be 0. It'll be false because there's the wildcard in front is saying it can have anything in front of it, but then it's saying it must end with shop. So that, obviously it doesn't, because it has that net1 material afterwards. Okay. This can also be a space-separated list for multiple things. So you can actually also be searching for the word, I guess, mat, star mat. Okay. And as long as it finds at least one of those two, then it will return true. So even if this was looking for SHP, which it won't find, it will still return true because it isn't finding this first one, but it is finding mat. Okay. Now, what if I capitalized this? So it's not going to find SHP, and it's actually not going to find MAT with a capital, so it's going to return false. But there is a case insensitive version called string case match, okay? And this will then be completely case insensitive, so it doesn't matter what you feed it here, and doesn't matter whether these have capital letters or not, it will return true because it has found mat and it's ignoring case. Right. So next one is, again, one of the very weird, very rare ones that is also backwards, okay? So pad 0 is about padding a number with leading zeros, okay, which is why it's called pad 0. So let's say we have a number like, I don't know, maybe let's feed it $F, and then, you want 5 zeros. But this is actually not going to work because, well, actually this will return a massive number. But that's because it's padding the number 5 to $F zeros, which, well, $F digits, which is 63. So again, this is backwards, and I have no idea why. So first you put the number of leading zeros, and then you put the number that you actually want. Okay. I guess it does make sense because it puts the zeros first, then it puts the number, but I still disagree with the way they've done this, because your first argument should be your primary argument. Whatever. So here, $F padded to 5 digits means 1, 2, 3, 4, 5. Okay. So when it's 63, it'll have 3 leading zeros. When it's 1, it'll have 4 leading zeros. When you go up to triple digits, it'll have 2 leading zeros. So it will always be 5 digits. Okay. That's what we mean by padding. It's not just flat out adding zeros at the front of $F. Okay. If we did that, so 000 plus $F, then it'll work, when we're here, it's going to give us 5 digits, but as soon as we go down, then it's 4 digits and then 6 digits. This is not how you do padding, okay? Use pad 0, okay? Right, then moving on from strings, let's dive inside to some geometry. So here I've got a box, right? And I'm going to drop down and attribute create again. And like I say, I just like using this to test things because you can switch types. So the first one we're going to look for is n points, right? Which is basically just the number of points on a particular piece of geometry. So we feed it a string, which is a path to that geometry. Now we could just go quotes and then maybe just start typing ... and like fill in the path and point to whichever object we're wanting to count the number of points on. But what we could do is use some of the expressions we've already used before. So how about op input path? And then we point to ourself instead and 0. So then we go, we're basically looking, saying, take the first input of whatever's plugged into me and go and tell me how many points that has, right? And it has 8 points, which obviously a cube does have 8 points. Then you have the same thing for in prims. Okay, exact same thing. You point to a node and it will look at the geometry on that node and tell us how many primitives it has. And obviously a cube has 6 primitives. So that's in points and in prims. Distance. So distance is essentially assessing 2 different 3D points or 2 vectors and telling you the distance between them. Okay, so the length of the vector of the difference between those 2 points. Okay, so if we feed it like 1, 1, 1 and 0, 5, 8 or something, the first vector is at 0.111, so in other words 1 on the x axis, 1 on the y, 1 on the z, and then the next point that it's assessing is 0 on x, 5 on y, 8 on z, and then it will tell you the distance between those 2 points. Okay, and you can include these in brackets, so in other words you can feed it 2 vectors instead of a list of floats, and it will still return the same amount. Okay. Then there's also length, which is just going to return the length of a single vector. So same kind of deal. We can go 1, 4, 8, and it will tell us the length of that vector. Okay. Centroid. Now this function is extremely useful. We use it all the time, right? So this is going to find the center point of a piece of geometry, and that center point, it can even be totally irregular geometry, and it will literally take the bounding box of that entire set of points and find the centroid of that. Okay, so centroid wants us to give it 2 arguments. It wants a string pointing to the object that we want to grab the centroid of, and then it wants a special type, and it does explain to you here the type. Now I keep referring to this help card just because it pops up nice and easily, but you really could come in here and go to centroid and actually read the help card. It's a lot easier to read this. Okay, so if you don't mind sort of having this open and typing, then this is going to help you learn a lot quicker. If you already know what this function is doing and you kind of just can't remember the order of the operations or the type or whatever, then this little help card helps, because it's got the information in there, but I mean a lot of it is confusing. This usage, but then it says centroid twice. This whole section is very confusing, so don't confuse yourself with this. Just actually pop this open. Okay. So anyway, what it wants is a type, and the type should be one of d_x, d_y, or d_z. Okay, for the corresponding components of the centroid. Because remember, a centroid is a vector. The center point of a box or whatever piece of geometry is a location, and location in 3D space has an x, a y, and a z coordinate. But it can only return a float. So it's asking you which one of those functions do you want me to return? Do you want the x component of the centroid, or the y, or the z? So let's point to an object. We're going to do it the exact same way. So op input path. And then, now the type is not a string. It has not specified string anywhere when it explains it, and it has even given examples, and you can see that it is not in quotes, so be careful of that. So it's capital D_x, and then we hit enter, and it will return. Now it's returning 0, but that is actually where our centroid is because it's at the origin. But if we, let's say, moved this to 0.9, 1.5, and 2.3, then you'll see here it says 0.9. Okay, and then we could go d underscore y, and it'll return the y coordinate, and we can do the same for z, right? And we could even, I mean, you can kind of copy paste this and put this into the different components of a 3-float point attribute, and then actually you'll see here that we've stored the centroid on as data on the points. So this can be really useful, so then each point knows, you know, how far away it is from the centroid. And I mean, in this case, obviously, we could get these exact same values by just referencing this center point here. But what if we have more irregular geometry? You know, what if we've put a mountain sop and changed the actual size and shape of this? Then the centroid is going to be different, you know, because the actual object itself is now warped. So it's going to take the bounding box and find the center point and return that for us. Okay. A very, very useful expression. So I'm going to clear all of these and return this to just 1. Okay, then another one which is similar is bbox, right? Which is bounding box. So this is going to calculate the bounding box of the object and then return one of the values. Now, if I middle click on here, you'll see that, so we have a center, which is the centroid. And then these 3 are the bounding box. It has a minimum XYZ, a maximum XYZ, and also a size XYZ. Okay? And we can access any of these numbers using this expression. So it's very similar to centroid. It wants 2 arguments. We feed it a path. So we want to look at op input path 0. Okay, so whatever is plugged into ourself. And then it also has another type, and the type is similar. It's capital D underscore. I don't know what this D stands for, but it could be something like dimensions or whatever. It seems to use it on the centroid and the bounding box, so I don't know. So D underscore, and then let's go to our help file. You see, sometimes the card pops up, sometimes it doesn't. So you're just going to make your life easier if you search it in here. So the type can be dx min, dy min. Okay, so all of the 3 in min, in max, or in size. Okay, so those are those 9 values that we saw. So if we want the dx min value, then now we have it. Okay, and if we middle click and go see, so x min is 0.4, right? And then we can say y min is 1, and then it's 1 there, right? So you can use this to do quite a lot. I mean, you could even calculate the centroid by taking the, for example, the max, so xyz max and the xyz min as 2 vectors, subtract them and then halve it, and that's how you find the center point. But obviously you don't need to do that because you've got centroid. But you can, I mean, there's a lot of things like that you can do, little tricks that you can do by knowing the exact size of the bounding box, and you know, I mean, I often use this in a DOP to automatically set the size of the fluid box to the size of my source. So, you know, then you don't have to set it on the first frame, and like, you know, so often, you know, you've got to figure out where your source is and then move your actual fluid container to, you know, make sure that there is some sourcing. Instead, you just use a bounding box and a centroid function, and it calculates the center point and calculates the size of the emitter on your first frame, and then from there on it does the dynamic resize, so it works perfectly. Okay. But then instead of op input path, you would just put a path to your actual emitter. Okay. Right, so that one's really useful. Now we're going to access attribute data. So I've created an attribute here, let's call it foo, and I will give it some value. And in fact, see, if I give it a static value of 1, then every point has the same value. But instead, if I feed it something like at ptnum, which is the point number, then it's going to give the point number. Okay, so it's going to be something different. Okay, or in fact, why don't I say rand at ptnum? So that way it'll be a random number per point, but it's different for every point, but it's between 0 and 1. Okay, so I've got a foo value. And now I want to access that on another piece of geometry. So let's say I have a sphere, right? And because this is a primitive sphere, it's only got 1 point, so I'm going to set it to polygon mesh and just have a bit fewer points. And on this attribute create, I want to access the value of foo on these points, but on this piece of geometry. So what I can do is run a point function. Okay, now don't get confused that point is not referring to the actual points. It's a point attribute, so it's the class of an attribute, right? So under here you see you've got detail, primitive, point, and vertex. So there is an equivalent function for each. There's point, prim, then vertex, and detail. Okay, so the function is named after the class. Then it wants, let's try and get it to pop up. In fact, no. let's get it in here. Let's see. This is why I've got it here, so that we can look at it, right? And it wants 4 arguments. Okay, so it wants the surface node, right? So let's give it the surface node. So we're going to be pointing to this object. Okay, so ... because we want to go from this object, we want to go up 1 level into our geometry node. Okay, and then we want to go to the attribute create 1, right? So there it is. If you double click, it'll fill it in for you. Okay, so that's the path to our surface node. So we've done the first argument. Second argument is point number, right? So which point number do we want to grab the value from, right? So we can put 0 or 2 or something. We can point to a very specific point if we want to, or we could put at ptnum, because then each point on the sphere is going to go and run this function individually. Point 0 is going to go to the surface and grab the foo value for point 0 of the box. Point 1 of the sphere will grab the point 1 value of the box, and so on. So often it's very useful to put this in here. Now, a lot of expressions cannot take per point data, or a lot of parameters cannot store per point data, but on an attribute create, these values can, which is another good reason to test expressions in here. Then attribute, so the name of the attribute, and that'll be a string. I mean, you'll see here it is explaining each one. The surface node, point number. So this is really useful. Okay, and you'll see it's a string that it wants. Okay, so we're just gonna put in quotes foo, and then the index is the last one. Now the index is about the component. What we're referencing is a single float value. Okay, so the component is always 0. But if we did have multiple components, so we took this to a size of 4, so it's a 4 float vector, there are 4 components. So this would be component 0, 1, 2, 3. In fact, it even says it there, right? So we would just say here 0, and then we finish the expression. Okay, and you'll see that it has grabbed, so point 0 has grabbed the value of point 0 of the box, then point 1 has been passed to point 1, and so on. And then the last one, see, these points have no equivalent point on here, so it will grab the highest point value. Okay, so point 8 is going to grab 0.7, 9 is going to grab 0.7, and so on, because they just don't have the equivalent point number. Okay, because there's only 8 points on here, but our sphere has 37. Okay, right. So that's how you use point. Now there is, like I said, there is a prim attribute, which if we change here to primitive, it's probably better, to be setting primitive attributes on primitives. But particularly here, the original attribute needs to be a primitive attribute. So then instead of ptnum, we'd say primnum. Okay. So we've got a random per primitive. Okay, and there's only 6 primitives because we're on a box. Well, now our sphere will do the same. It'll grab all those random values, right? The same as if we go to detail, allows us to point to so with point and primitive, you have to actually refer to which point number or which primitive number. But on detail, it's got fewer arguments because it actually just needs to know where. So I'm just going to undo and get back to this point. Oh, by the way, on prim, you should use at primnum, just so you know. But anyway, you could switch to detail, but then actually we've got too many arguments. It wants to know the path, and it wants to know the attribute name and which component, but it does not need to know which primitive or not. I hope you guys all do know that detail means these are attributes stored on the entire piece of geometry. Okay, so there are so many points, primitives, vertices, and polygons, but the entire surface object itself stores a few attributes, and those are stored under the detail class. Okay. Things like your shop material path, if we put a material node here, are stored in detail. Well, I guess we'd have to assign it a material. But then, oh yeah, sorry, it can be stored in primitive, but a lot of the time it is stored in detail. Okay, and there's a lot of other things, especially when you're packing geometry as well. A lot of things are stored on detail level or primitive level, so just check where it is first. Right, then one final set of expressions that I want to show you guys is just something. Look, it won't be relevant right now, but if you know any Python, it will be relevant. Sometimes you need expressions that allow you to, within the context of Houdini expressions, you want to run a Python expression. Without having to change the entire parameter to Python as a language, you can just execute a snippet of Python inside of a Houdini expression, and you can do it vice versa. Python has similar expressions that allow you to run HScript expressions or to run like Vex code and all that type of stuff. Right. So in here we could just so we're going to type Python expr, so expression, and then f. Okay, so there it's autofilling. Okay, so the f is for float. It's very much like I'm sure you've seen. There's always, or most of the time, there are 2 types. There's the float version and the string version, because they do not seem to automatically cast from the one to the other. So it is important to choose the correct one. There's the float version, there's the string version. So we're in float now, so we're going to choose float, and then in quotes you can just put the Python expression. So we do something like, okay, well, we're setting an attribute here, so we just say who.time function, okay, in the quotes and in the brackets. And so the time would be stored there. So this is 0.75 seconds, okay. There's a lot of other functions you could do in here, right? And then there is also the string version. So if we change this to a string, and then we say Python expression string, okay, and then same in quotes, we just put something like who.application version string. So this is going to return a string of the version of Houdini that we're busy running. So that can be quite useful to, when you've got an HDA, is just checking that your user is running the right version. Maybe there's a certain fix beyond a certain version, or if there was a bug that doesn't work on a particular version, then you can check for that and then create like a switch that switches between maybe a workaround and not inside of your tool. So there we go, it returns a string of the version number, and you can see at the top here it is correct. Right, so that concludes HScript and HScript expressions, and that concludes week 1 as well. So I mean, obviously you guys can smash through all of these lessons as quickly as you want, but like I said, if a quick and easy way to do these would be to do one a day every week, because then, you know, you can easily find, you know, 20 minutes a day to just listen to the video. And I would encourage you guys to go and practice in your own time, go over this and make sure you understand these. I promise you're going to use these every day, especially the more you learn about expressions and coding. You know, you learn a few useful ones, you start using them, and then suddenly it just kind of opens up and you start exploring this help file to see what else you can do. It's really fun to just start looking through here and going, oh wow, okay, cool, I can do that, and oh wow, like what is this? This looks interesting. Let me read what it does. Let me try it. Often it gives examples. So I would encourage you guys to try your best to learn these. You will use this everywhere in Houdini. But this is also going to form a really solid foundation for learning Vex. A lot of the same principles transfer, and a lot of the same expressions actually exist in Vex. Okay, and the same thing with Python. What you'll find is that the more languages you learn, the easier it becomes to learn a new coding language, because they are pretty much all the same, except for a little bit of, you know, a few little gotchas, a few little rules and syntaxes, but that's it. They're pretty much the same thing. Okay, so I hope you found this all useful. If you have any questions, please feel free to ask. And next week, in the next lesson, we're going to be starting with Vex. We're going to cover it in a similar way. So we're going to start really basic. We're going to build up, but then be prepared, because we are going to ramp up and start writing big chunks of Vex code. So make sure you're following, make sure you practice and learn, and ask any questions that you need to, and then we're going to go from there. Okay, so thank you very much for listening, and I'll see you guys in the next lesson.